The seasoned pros at the Tuning School and Mustang Dynamometer are teaming up to show you how to tune using a Mustang dyno so you can do the best job possible when doing different types of tuning. We'll be going over full throttle and part throttle tuning. Let's get started. Start by driving the car onto the dyno. Once the wheels are between the rollers, select the down option in the Powerdyne lift menu to lower the lift. The tires should settle between the rollers. Strap the car down, but not too tight until the car is centered. Drive the car slowly to center it, then finish tightening the straps.
Pull it out, double lock it. Then you tighten the front down really tight.
Clamp the inductive RPM pickup sensor to the spark plug wire, with the side that says spark plug facing towards the spark plug. The air-fuel ratio sensor can be attached to the tailpipe or to the headers underneath the car.
This goes into the OBD2 port. Set up the quarter-mile run, go to tests, timing, and then quarter-mile sprint. And so we're set up now to do a quarter-mile. After we hit the start button, you'll see the tree drop, and then as we go along, it's going to fill in the data, and at the end, you'll see the quarter-mile ET and mile per hour come up here. Okay? And this first test, we're going to do our shift points at 5,000 RPM. See, we ran a 14.7 at 99 miles an hour, shipping at 5,000 RPM. Makes this a pretty tuning tool, so you can check your shift points and set them appropriately until you get the best ET mile per hour, so you don't have to do it at the drag strip. One of the great things about the quarter-mile run feature of the Mustang dyno is you get to actually see how the vehicle is going to behave all the way down the quarter mile, instead of just going through a single pull like most dynos will have you do. So what you can do here is, as you see on our Camaro that we tested on, you can see every single gear shift, you can see the horsepower, you can see the torque, to help you figure out when you should be shifting. You can also look at the air-fuel ratio on every single gear change and watch it throughout the entire run to really give you a great idea of what's going on. And so what we want you to understand is that the quarter-mile run feature on the Mustang dyno is more than just a single, see how close it can be to the real thing kind of test. It's actually a very useful test because you can save your customers a lot of guesswork and a lot of time that they don't really have when they're actually at the drag strip. Because you don't usually get a lot of passes. You're usually waiting in line more than you are running. So if you can give them a tune that you know is right the whole way down the quarter mile, you're just going to have that much of a better service that they're going to come back to you for over time. Alright, so here we are at the main Powerdyne screen. We're going to do a standing start acceleration test to see how long it takes to hit a certain top speed. and we chose 175 to see how long and how far it took to get there. So we're going to go to tests, and then we're going to go to timing, and then standing start acceleration. And this is a useful test to see, in a mile, how fast you can go, which is good for the people doing like the Texas mile or 1 mile runs to check their top speeds. So we've set it up to tell us at 175 miles per hour how long it takes and how far it took to get there. Go ahead and start the test. Obviously, we didn't hit our target of 175 miles an hour. We were just a bit optimistic about that with that car. But what that does show us is how well we can get a realistic estimate of the top speed of the vehicle, because the dyno is loading us properly for wind and drag and aerodynamic resistance and all of those good things. So we're going to go try this test again one more time with lower speed. Pause the video here at 141 miles an hour so we could look at the data, and you can see that it took 24.92 seconds to go 0 to 140 miles an hour, and it took 0.62 of a mile to accomplish that, which is just a great feature to see the top speed of the vehicle. We could let it go longer if we wanted to just keep going until we hit 1 mile, or we could just kind of play with it, make sure everything's safe, and give the vehicle back to the customer with the knowledge that it's going to be tuned well, even at such a high speed. Okay, so next we're going to be getting into the part throttle tuning. We're going to be using vehicle simulation mode. So in the dyno software, we're going to go up to tests, then diagnostics, and then vehicle simulation mode. And we like to use this mode for our math tuning because we find that it provides the ability to get into the range of the math that the vehicle would normally experience. And so what we're going to do here is open up our HP tuners. We'll overlay that on the screen. So what we have here is an overlay of the vehicle, and we're just going to have the vehicle do what's called a step test. We're going to take it up in about 500 RPM increments, starting at about 2,000 RPM up to about 4,000 RPM. And so we're going to go ahead here and just slowly bring it up, and you'll be able to see in the chart what's the error percentage, which is actually fairly high. This is telling you how far off the air fuel is, and this is a normal step in the process we teach of math tuning. So you'll see the vehicle simulation test is what we recommend to do your math tuning with, because it really provides a great way to get all the way through the math frequency, all the way up to a normal driving range of 4,000 RPM at part throttle. Alright, so tuning the math is actually quite simple compared to doing VE tuning. This is also called speed density, which a lot of aftermarket systems have that do not have mass airflow sensors. And what we're going to be doing here is putting the overlay up with HP tuners so you can actually see the VE table, which is based on RPM and manifold absolute pressure. We like to use vehicle simulation mode to do our first test to dial in the VE table, because this is what the vehicle will normally experience when driving along on normal flat roads. So while we're doing this test, we'll be trying to do a good complete part throttle test. That means in 500 RPM increments all the way up to about 4,000 RPM, because that's the typical driving range of part throttle. that we've filled in most of the driving area that we can using vehicle simulation mode, we're going to go ahead and bring the truck to a stop. We'll just let it coast down so we continue to fill in those areas as it normally would see coming to a stop. And then after we come to a stop, we'll go ahead and put the overlay up of the VE table so you can see what we need to work with here. Alright, so here we have the VE table, and this is the results from our test using vehicle simulation mode. As you can see, we got up to 4,000 RPM, starting at just off idle, and we were able to get up to about 55 or 60 kPa, which is about mid-range on the throttle, and that's what we wanted to see, because that's usually what the vehicle will encounter during normal driving on flat roads, not very mountainous or hilly terrain. But the problem is your customer might experience some mountainous terrain or be towing up a hill one day. So our goal is to make sure we thoroughly complete this table, and we're going to use what's called the Pro test. That's our next test we're going to have come up, and that's going to hold us at a certain RPM. We've chosen 2800 for this test. We're going to show you how that works all the way through the table. Alright, so we're going to need to go on up in the Mustang Dyno software to tests, then diagnostics, and then down to Pro test. And now you'll see down here we get to choose the type of control we want to use, and we're going to pick engine RPM. We could use a number of things like vehicle speed, but we're going to pick engine RPM, and we're going to set it to hold us at 2800 RPM no matter what we do with the throttle. So we're going to go ahead and apply the test and run the video, and then we're going to get the overlay up here of the HP Tuner software so you can see map pressure and engine RPM. Alright, you can see now that we're headed up to about 2800 RPM, and what's going to happen is the dyno is going to hold us there, and that's going to allow us to continue to push down on the throttle, which you can see as TPS on the screen, and then we're going to watch the histogram as we work our way down through the table to fill in all those cells. And we would continue this test going up at about 500 RPM increments until we've completed the table all the way up to about 4000 RPM. So the next test we'll be doing is putting the vehicle on a 10% grade using the Dyno's grade feature. And so, you know, most of the time when we do our tuning on VE tables, we normally don't even think about these things, but in order to do the best job possible for our customers, we have to be sure that we get all areas of the table, and that includes the areas that we'll be actually getting if the customer ever goes up a steep mountain or any type of towing. So we can use this feature to simulate either of those. And so as you can see, we've gone ahead and we're accelerating now. And unlike the first time we used vehicle simulation mode, we're currently up over 65 kPa all the way up almost to 100, which tells us that the engine is really struggling a lot more because of the increased load. So we really have a great simulation going right now of towing up a hill or just driving up the hill. And now we know exactly how the engine is going to operate, how we need to do tuning in that area to provide the best power and the best fuel economy for those zones. Alright, so now we've got our overlay up on the screen, and we can see the final results of using the 10% grade on the dyno here. And we can see that unlike the first test, you know, we're totally down in the bottom half of the table. We're pretty much over the 45 kPa and higher area, and most of the time was spent over 70 kPa. Even though we weren't at full throttle, the engine was struggling so much to pull up that grade. So now we know that we've covered the entire map, so that when we give this vehicle back to the customer, we're confident that we've done a complete and thorough tune through the entire VE table.